All right, let's do this. I'm once again winging it. Let's see how far we get. Okay, so we're thrown from the ground at an angle. 53.1, that's the same weird angle as before. I wonder if we're going to get another 3, 4, 5 right triangle. I bet we do. So we got 20 meters per second at the weird angle. That helps no one. We're going to figure out what is that velocity in the x direction and what is that velocity in the y direction. If this is theta, this is opposite that angle, so that's 20 sine theta. And this is adjacent to that angle, so that's 20 cosine theta. So that's 20 times the sine of 53.1. I'm going to be shocked if this is not a whole number. 16. Okay. 16, 3, 4, 5. Is this going to be 12 then? Cosine 53.1 times 20. 12. Look, I can tell the future. So that's 12 meters per second. 16 meters per second. Okay. Now that we have like useful stuff, let's see how useful is it. We've got a rock. We're going to go up and back down. We want to figure out how high does it get. So I'm going to start, let's start from the ground and then go to here and call that the end of our journey. So our initial velocity, let's do the y direction because that's like useful. In the y direction, our initial velocity is 16. Our final velocity, they didn't tell this to us, but we are physicists now. We figured out that at the top of its journey, the velocity in the y direction is 0. It's still moving. It has horizontal velocity because it's moving like sideways the whole time. But the x and y components operate completely independently. So the final velocity in the y direction is 0. The acceleration is 9.8. How far did we get? That's what we want to know. And how long did it take? We don't know. We don't care. So we need an equation that has x in it and does not have time in it. That is the squaredy one. Okay, so vf squared equals v naught squared plus 2ax. So the final velocity is 0. When you square 0, it's still 0. 16 squared plus 2a is 9.8. X is, we don't know. Okay, so 0. So I'm going to subtract this. So 16 times 16. I don't need to go this fast. I'm going to slow down. This is 0. This is some number. 256. 9.8 times 2, 19.6. So now I need to subtract 256 on both sides because we're trying to get x by itself. So now I'm going to divide by 19.6 and get 13.06 meters. And I might think, well, isn't it negative? I was like, well, yeah, but I was lazy and I put acceleration is 9.8 instead of negative 9.8. You know that the ball didn't sink into the ground. It floated above the earth. So you can logic that through. So I got 13 meters. Is that the right answer? That's the real question. Is that one? Yeah, we got it. All right. Good work, team.